Hi, we're the Epicenter engineers, and this is our low-cost seismograph fed presentation. Who
Hi.
are we?
Hi, I'm David Graves, Industrial Systems Engineer.
I'm Aaron Brooks. I'm an aerospace engineer.
Hi, my name's Norv. I am biomedical engineering major.
I'm Hayden Gephead. I'm a chemical engineer.
So what are we about? We are about creating a low-cost seismograph as per our title. These are made from materials gathered in any normal civilian areas, and our idea is if we are able to gather these materials and prepare for earthquakes and disasters that relate to seismic activity, we can negate property damage and casualties.
Our project aims to detect seismic activity. These mostly occur in subduction zones, as shown in the black lines on the map. But uplift quakes can occur in the middle of plates, such as Hawaii and Africa. Many intraplate quakes are hard to predict, such as the ones in the eastern U.S., making them even more devastating.
So our objectives and constraints for this project were, of course, to build a low-cost seismograph, which has to actually be between 0.1 and 1 hertz. And of course, it has to be a fully built one that can detect ground motion by itself. And it has to follow one of the following prototypes and stay under a budget of $60.
For our prototype, we based ours on the provided prototype of the K&J magnetic seismograph, which uses a magnet that moves inside of a copper coil. This produces eddy currents. We then measure those with a Arduino and then send those to our computer for graphing.
So some of the problems we faced were mainly in the construction and use of some of our ground recording components. So for example, the coil probably took the longest because we first failed in making a coil when one of the wires snapped in the construction, and so we had to actually restart entirely. But we got it the second time with some better methods. And then again, another problem with the coil was the coating. We didn't know how to remove the coating that prevented being able to measure the voltage on the coil, but Dr. Titus helped us come up with a plan for that, so thank you.
Some of the other problems we faced was the spring. We were forced to adjust our model because we needed to account for the exact length that we needed for the required frequency. We also had problems with our electronics as the wiring diagrams provided were not very clear, and it was difficult to find the software. But thankfully, through trial and error, we got the wiring to work, and with the help of the guru, we were able to get the software to work.
For our engineering design cycle, we follow the normal one, in which case we start by asking what type of prototypes we want to use, how much we want to spend on the actual project itself, where do we gather the materials from, etc., where do we want to test it. We then begin to research on our specific model, which is the KJ Magnetics prototype. And we imagine it out in a CAD software. We made the blueprints and then start by gathering the materials and then test it out before Fed Day.
This is the CAD design of our seismograph with the parts list on the right.
So for our project budget, again, we had to stay under the $60 budget, but the materials that contribute to that budget are only the ground motion detecting materials. So on the left side, you can see all of the materials and their price. That is for the ground motion detecting, so to actually detect, ground movement. Whereas the signal conditioning and the cosmetic items are on the right, adding up to a total cost of $44, but the actual budget is $31.28.
Before Fed Day, we tested our seismograph for approximately 48 hours. This is a 6-hour cutout of the data. This is also magnified to 500. This is very small background noise from the Earth and from Sullivan Hall.
For future improvements, if we were to further our project currently, we can improve on the copper spools that we use as the main components inside our prototype. That could be made with less faults and less inaccuracies, and then we could modify our casing to be able to be more sufficient in terms of materials. And these are our pictures during our Fed Day. We are able to place first place compared to our other E101 sessions.
Our best advice for incoming freshmen is to get started early. It may seem like you have a lot of time, but it goes by fast. Be sure to reach out to your guru and other experts, and you're not alone on this project. Leave time to fix things and test things.
These are our references. Thank you for listening. It was a great time.
Go back.